In this video, we will demonstrate the cable sizing tool. The cable sizing tool can be used to verify existing cable types in the network and to suggest recommendations to improve cable types, in order to meet voltage, thermal loading and short-circuit constraints. The cable reinforcement study case should be activated. Here you can see the 400-volt network. The network is colored to indicate feeders, and here you can see one feeder, FD094. We are going to carry out a cable sizing analysis on this feeder. If we double-click on the substation at the center of the feeder, a detailed graphic of the substation is opened. We will first run a load flow. We see that, with the existing cable types, the feeder has a minimum voltage of 0.91 per unit, a maximum voltage of 1 per unit, and a maximum voltage drop of 9.33%. This voltage drop is quite high, and could be improved. In the cable analysis toolbox, this icon is used to open the cable sizing command. We will use the cable reinforcement method, where cables are selected from a user-defined selection of cables and against a user-defined selection of constraints. Ensure that the feeder we wish to carry out the calculation on is selected. And to start with, we will carry out the verification only. A balanced network representation is used. On the constraints page, we have selected the option thermal constraints, and a maximum thermal loading of 100%. The option voltage constraints along feeder is also selected, with a maximum voltage drop of 5%. We execute the calculation. Results are shown in the output window. In the first section, any cables which are exceeding their thermal loading limits are identified. You can see here that 3 cables exceed the 100% loading limit. Cable LN1216 consists of a number of subsections. It is subsection 2 that is overloaded. The second section shows every terminal in the feeder where voltage constraints are violated. You can see again that the maximum voltage deviation along the feeder is a minus 9.33% voltage drop, which corresponds to a bus voltage of 0.908. So on the basis of these results, you might want to consider altering the cable sizes in the network to improve performance against the considered constraints. We open the cable sizing command again. This time, we will change the mode to recommendation. Look at the cable types contained within the selected cable type folder. This is the library of cable types, from which the cable sizing tool will determine the best types of cable to use. Notice that on the Cable Analysis tab, costs have been attributed to each of the cable types. Costing will therefore be factored in when optimizing the selection of the cable types. On the constraints page, we will use the same options as before. On the output page, the Modify Cable Types box is checked, with the option to create a new variation with recommended cables. The command is executed. You can see that a new variation has been created and activated, containing the new cable recommendations. In the results summary you can see that load flow results have now improved. The minimum voltage is now 0.95 per unit, the maximum voltage 1 per unit, and the maximum voltage drop 4.98%. This is within the voltage constraints that we specified. Looking at the output window, You can again see the report of constraint violations with the existing cable types. A third section shows the original and replacement cable types, and the maximum loadings calculated with the replacement cables. In the final section you can see the costs of the reinforcement,